Good evening, Balf House, or good morning. Sorry the answer's a bit late getting to you. Can time escape a black hole? Well, wherever you read that statement, even time cannot escape a black hole, that's a bit misleading. And hopefully I'll be able to explain why. I'm sure you'll have seen the computer graphics which try to show you how space and time can be bent just like a rubber sheet when you drop a heavy weight, say a planet or a black hole, onto the sheet. Now you must remember that that is just a description. Space-time isn't really a rubber sheet, and by the way, you must stop immediately thinking about space and time. There is only space-time. The two things are absolutely and inextricably linked. You could no more pull time away from space than you could pull depth away from height. That is why we refer to time as another dimension, or rather why calling time another dimension describes it better than virtually any other word we know. Space-time is one thing. When you drop a planet into the middle of space-time, not only do you stretch the space, but you also stretch the time, the passage of time within that gravitational field. You should remember that matter tells space how to bend, and space tells matter how to move. But of course, when I say space, I mean space-time. The reason I mention that, about space-time telling matter how to move, it's because in general relativity, gravity is not a force. It is the byproduct of the curvature of space-time. This is one of the problems we've got when we try to incorporate general relativity with certain other theories, namely quantum mechanics. The analogies of both systems are mutually incomplete. We have to have different models for different scales and different conditions. No one model fits them all. So you'll have heard of the force of gravity. Well, in general relativity, there's only the curvature of space-time, which fulfills the same role as what we would normally call the force of gravity. Which model, the force or the curvature of space-time, is more accurate, we don't know. They're just models that we use to try and understand what's happening. To get a handle on why we call it space-time and why we know that the two things are bound, you need to start looking into general relativity. I'm sure if you search Einstein and space-time, you'll be able to start your search there, and then get deeper into general relativity once you've got well, that'll just naturally happen. It'll lead you into general relativity. And don't be afraid of it. If a dunce like me can get a certain grasp on it, anyone can get a grasp on it. Do not be afraid. Just read it, and if you enjoy it, read some more. Now, remember, we describe space-time as behaving like a rubber sheet, but of course it isn't a rubber sheet. It's just a model that we use to understand what's going on the large scales in the universe. What we call space-time and what we say describes a bit like a rubber behaves a little bit like a rubber sheet isn't a rubber sheet. Space-time in a way may not exist. It's just a model that we use to understand what happens. So your question about a black hole and time escaping it. Time is part of the fabric of space-time. If a black hole moves through a region of space-time, we describe that space-time in vectors, positions in the 3 dimensions of space and the one in time. And obviously those positions can fall within the event horizon of a black hole, which is where the blackness starts, which is where the gravity becomes so intense that light cannot escape under any circumstance. And so the the black hole drifts along, it goes along the rubber sheet of space-time, which is just a description, and into the black hole. Well, it's really a position in the universe. Your question is like saying, can a position in the universe escape from a black hole? It's kind of unanswerable. From a scientific point of view, it's a meaningless question. It's just a four-dimensional vector in space-time. That's what time is. It's just one of those vectors, positions. So it's meaningless to say, can time escape from a black hole? It's rather difficult to explain in 5 minutes, but you will get the idea of why it's a meaningless question if you look into the origin of the idea of space-time, which came through Einstein, which came through general relativity. And don't be afraid.